In 4.2, we will be reviewing or going over how to graph piecewise functions and build piecewise equations. On the top, I'm just going to make a note. The equation for a line, we're going to use point slope form. It'll be y equals m, x minus x1 plus y1. If I have a quadratic or a U shape, I'm going to use vertex form, which would be a x minus h squared plus k. Hopefully you notice m and a look similar, x minus h, parenthesis, this one has a power, the line doesn't, plus a number. They are very similar. And then for absolute values, when they make a V shape, it's y equals a x minus h plus k, and they have the absolute value bars rather than parentheses. So for our first piecewise, I'm going to write f of x equals, and then I'm going to place my bars. So then I'm going to look at my pieces. This line has a slope of down 3 over 1, down 3 over 1, down 3 over 1. That means I'm going to have it going down 3 over 1, or just a negative 3. Then I pick a point. It does not matter what point. I could pick negative 2, 6, 0, 0, or I could pick 1, negative 3. I'm going to pick the point negative 2 up 6. Any point on this line I could select to be my point. When I write my equation of a line, it's a line, I'll have negative 3 over 1, x, opposite of minus 2 is plus 2, with a plus 6 outside. That is the equation for this line. The expression for this line, sorry. And then I need to write an inequality. My inequality for this segment is between negative 2 and positive 1. So I will say x is between negative 2 and 1. Now the reason I put these equal bars, the equal, is because there is a closed dot and a closed dot. Next section, I have from here to here. My slope is going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Positive 1 over 1. X. I can pick any point I want. I'm going to pick the positive 3 down 1. When I plug that in, it'll become a minus 3 with a minus 1 outside. This piece, this pink section, this equation, is between the numbers 1 and 5. This dot on 1, I closed it, so I'm going to leave this one open. Then on 5, it's a closed, so I'm going to close it. Next section. from here to here, it's going down 1 over 2. I pick a point. I'm going to pick the 7, 0. This point 7, 0, I would write x minus 7 plus 0. I then determine where it is between. It is between 5 and 7. I already closed that dot on my previous inequality, so I'm going to leave that open, and then I'm going to close the dot on the 7. So I have my 1, 2, 3 pieces of that image of the graph. Let's try the next one. I have 2 lines. I don't see dots. Because I don't see any dots, I'm going to assume that there are arrows. So I am going to do this line first and assume there's an arrow because it looks like it keeps going off. So for my function, this says it's p of x. This line, its slope is 0 over 1. Zero over 1 is really just 0. You could just write 0. Totally fine. Then I pick a point. I'm going to use the point, let's see, 0 up 3. Now when I have 0 times the parentheses, 0 times the parentheses will make it go away, and you'll just be left with a positive 3. This is just to help me use the formula. Really, I would just type in that this line is at positive 3. And it is at positive 3 between, let's see, it goes left forever. So anything less than 2. So whenever x is less than 2. This inequality is pointing the direction that the line is going. It's going to the left. Left of 2. And then my next. This piece is going here. It looks like it goes off, so I'm going to say there's an arrow. Up 2 over 1, up 2 over 1, up 2 over 1. Then I pick a point. I'm going to pick this point right here at 3, 5. That means I would have x minus 3 plus 5. And the inequality for it is anything to the right of 2. So I'll say when x is to the right of 2. When x is greater than 2. These are the 2 pieces of the graph. Oh, we need to close one of them. I just realized that. This says left of 2, and this says right of 2, but I need the dot filled in on one of them. I can pick which one is filled in. So I am just going to put a line under my last one so that it actually touches that point. Alright, next we have a segment from here, and there's a dot, and it's a closed dot, to here. That's a closed dot. My line is going down 2 over 1, down 2 over 1, down 2 over 1. I pick any point on that line. I'm going to use the 3 comma negative 5, x minus 3 minus 5. And it is in the location between 0 and 3. So I would put x is between 0 and 3. And because both of these dots are closed dots, I'll say that they're equal at 0 and 3. Next piece, closed dot, it's going up 1 over 1, 2, 3, 4, up 1 over 4. I can pick any point I want. I'm going to pick 4, negative 1, and say that x is minus 4, minus 1. Then I define where it's between. It's between 4 and 8. And they are closed dots on both, so they will be equal. Dot, closed dot, closed dot. It's going up 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. Up 4 over 1. X, I can pick any point. I'm going to pick this one at 3, 7. So I put x minus 3 plus 7. And it is between 1 and 3. X is between 1 and 3. They're closed dots, so I need to close my dots. Then I have this piece. Ooh, that's at 3.5. That's interesting. So it's going down a half. This is gonna look weird. I'm gonna do this one off to the side so I can enter it on my calculator. It's going down 1/2. I'm gonna use down 0.5 over 1, 2, 3, 4. I might just type it that. I'm just gonna write it that way. Down 1/2 over 4. Then I can pick a point. There's no really nice point, they're decimals. So 7 is at 0.5. So I would say x minus 7 plus 0.5. That is a weird one. It happens. So then this is between 3.5 and 7. And I check my dots, they're both closed, so I close my dots. There are a lot of examples in this unit. You are welcome to skip through. You don't have to watch all of them. I just wanted to make sure I provided enough examples for it to click. All right, next one. I'm just gonna say f of x. I only have 2 pieces. I have here and it continues going, and I'm going to check. It's going down 1 over 1, down 1 over 1, down 1 over 1. That's just a -1, and I'm going to use this point right here, which is -5 comma -4. It's called a vertex point. And this inequality happens when x is to the left of -5. The left side. Then I have to do the right side. So on the right side, my graph is going up, up 1 over 1, up 1 over 1, up 1 over 1. So it's not a negative anymore, it's now a positive. And I'm going to use that same point they touch at. And this inequality is when x is to the right of -5. And because this is a closed dot, one of these needs an equal sign under them. I'm just going to put it under the last one. Okay, from there, if it does not ask for a piecewise function, if it wants an absolute, because this makes a perfect V shape, see how these match but the slopes are just one's negative and one's positive? I would write that f of x equals, my V shape is opening up, x plus 5 minus 4. So sometimes it's easier to write it as an absolute value rather than a piecewise. Both of these are just different ways to represent this one graph. Question 5. Alright, left side is going down. This is kind of hard to see. 1 second, let's see if I can. I just want to make sure I'm counting right. Okay. Let's try and count. This green one's going down 1, 2, over 1, 1, 2, over 1, 1, 2, over 1, down 2, over 1. Oh. I lied. Sorry, I lied. It's going up 2 over 1. As I read left to right, it's increasing. Sorry, this side's going up 2 over 1. The vertex is at 1, 2, 3, up 6. So I'm going to say x minus 3 plus 6. And that is when x is to the left of 3. The right side is going down. Down 2 over 1. Down 2 over 1. I'm going to use the same point. And then I'm going to say when x is to the right of 3. That's where the pink equation is. I'm going to put equals 2 so it fills in the dot. If I write an absolute, which I can because my slopes match, right? One's going up and down. They're the second, let's see, g of x equals, my graph is going -2. If you want to put it over 1, completely fine. Then I'd have x minus 3 plus 6. Next, I have a closed dot, closed dot. My graph is going up 2 over 1. Up 2 over 1. I'm going to use this point at -2 up 6. That will make it an x plus 2 plus 6. And it is between -6 and -2. Closed dot, and I'm going to close this dot here. So I closed that and I closed it. Now the next line. It's going down, closed dots. Let's see what it's going down by. 1, 2, 3 over 1, 1, 2, 3 over 1, down 3 over 1. I'm going to use the same point. And it is between the numbers -2 and +2. And they're closed dots. I've already closed that one on the -2. I've already closed it, so I don't need to close it again. This one I have not, so I need to close it. I cannot build an absolute value for this equation because the lines don't have matching slopes. Okay, next. Ooh, I have 3. I have 3 different pieces on this one. Okay, so from here to here is at a height of 1. And it's a flat line. So I'm just going to use the 1. It is at 1. Between x is let's see, 4, 5, 6, 7. Between -7 and -4, and they're closed dots, so I close my dots. And then we have this line, which is at +2. Flat lines are super nice. We just say +2. And it's between -2 and 1. Both closed dots, close. Then I have a third line. It's at a height of 3 between one, 2, 3. Wait. I can't. And these were printed pretty. 1, 2, 3, 4. Okay, yeah, 3 and 6. both closed dots, closed dots. Question 8. All right, here we go. Here to here. It's going down. I need a mark. Okay, that'll help me count. Down 1 over 1, 2, 3, 4, 5. Down 1 over 5. I'm going to pick this point at negative 5, 6, 7. Up 4. X plus 7 plus 4. That is between negative 7 and negative 2. This is a closed dot, and I'm going to close that one as well. And my next piece, this goes down and up. It makes a V shape. If I want to do a shortcut, because this makes a V, I can say that it's going up 1 over 1. 1, 2, 3 over 2. Up 3 over 2. Up 3 over 2. Absolute value, x. This is at 0, 0. So I would do minus 0 plus 0. Rather than writing it as two separate lines, I can write it as an absolute value, and then I define it as it being between negative 2 and positive 2. This I already closed. I'm going to close the positive 2 side. That dot is now closed. Then I have from here up to here, which is going up 1 over 1, 1, 2, 3, 4, 5. Up 1 over 5. I'm going to use this point that's at 7, 4. It'll be x minus 7 plus 4. And that's from negative 2 to 7. I already closed this dot above, so now I only need to close the 7. Alright, now we are going to graph. I'm going to be making tables. Let's see. I'm going to end this video and make a second one so that they're opposite. So this will be the end of building equations for a graph.